Here we are in the last video that closes the discussion on the elements at the base of the functions of the engines. We will see how the advance works on injection and how this affects ignition for diesel engines. Over the years, diesel technology has evolved. In the past, injectors worked with a maximum 160/200 bars, and the injection took place indirectly. Today, however, they work with much higher pressures, up to 2,500 bars, and injection takes place directly inside the combustion chamber. Let's see the differences between these two injections. Indirect injection, also called pre-chamber injection, is an injection principle that was used until the 1990s in diesel engines. In this system, there is a compartment called the pre-chamber, cylindrical or spherical in shape, obtained in the engine head, with a duct on one side that communicates with the main combustion chamber, while on the opposite side is the injector. During operation, the pre-chamber reaches high temperatures, and this reduces the ignition delay, thus facilitating the ignition of the air-diesel mixture in the cylinders. It is now an obsolete system, characterized by the fact that the combustion chamber is divided into two parts, a main combustion chamber and an antechamber. The injector is not located in the combustion chamber but in the pre-chamber. By direct injection, on the other hand, we mean the injection of fuel directly into the combustion chamber. Without the use of the pre-chamber, the turbulence must occur in the combustion chamber, so a high atomization of the diesel oil is required. Furthermore, the fuel is also injected with a higher pressure of at least 500 bars. The operation of this type of injection has also led to higher efficiency of the diesel engine, given the lower thermal losses and higher pressure in the combustion chamber. Now that we have seen the differences between indirect and direct injection, let's analyze how the injection advance was calculated according to the system used. Based on the injection systems developed for diesel engines, the injection advance can take place in various ways. In the simplest system, called the injection pump, is adjusted manually thanks to a spring. If the advance is not correct, there is a risk of loss of power because the engine revs increase and there may be excessive smoke in the exhaust gases. The subsequent generation of the injection pump system is the unit injector system, a direct injection system, which integrates a pump for each individual injector, mechanically operated by the camshaft. The main advantage of this system is the ability to reach higher injection pressures, which consequently reduces the injection times and improves the pulverization of the diesel, allowing achievement of higher performance. Nowadays, all diesel engines are equipped with common rail. Because it has brought a breakthrough in the automotive sector, it is the most advanced and allows detailed control of very important maps in the engine control unit, such as the injection timing and the quantity of fuel to be injected, in order to precisely control the injection advance. For all systems, in the event of limit conditions, the following effects will occur. In case of excessive advance, there is a risk of knock in the head and a very dangerous situation for the vehicle. In the event of a delayed injection phase, there is a risk of excessive loss of power, as well as excessive smoke in the exhaust gases. The injection advance, also called injection phase, is able to regulate the opening moment of the injectors or timing, based on the engine speed and the calculated torque or the quantity of fuel to be injected. This, therefore, allows you to impose the start of injection in the cylinders and consequently to predict when combustion occurs. Let's get a better understanding of the concept by closely analyzing a map of the injection phase present on a common rail diesel engine. The values in this map are expressed in degrees before the top dead center as a function of the engine speed and the engine control unit calculated Newton meters. Let's use the reference of 3,500 engine revolutions and 420 Newton meters. We find a value of 13.74 degrees before top dead center. This means that at that engine speed and those calculated Newton meters, injection will take place 13.74 degrees before the rising piston reaches top dead center. If, on the other hand, we find negative values, for example at 1,500 engine revolutions and 120 Newton meters, we get a value of negative 1.13 degrees before top dead center. So it means that the injection will take place after the piston has already reached its top dead center and is down towards bottom dead center. Now that we have seen how the control unit controls the injection advance, let's take a look in detail at how the technology has gone from a single injection to different types of injections, and how these have brought significant improvements to the engine. Nowadays, diesel engines work with multi-injections, and this has led to major improvements in terms of both efficiency and consumption. One of the most famous fuel systems is the multi-jet, a fuel system designed by the Fiat Group in 1999. The first application was made on the Alfa Romeo 156 1.9M Jet 16V in 2002. This system, too, has undergone several evolutions over time. In 2009, the second generation of multi-jet 2 engines were presented, made more efficient than the previous one and Euro 5 approved. At the end of 2013, however, the restyling of the Alfa Romeo Giulietta made its debut with the evolution of the multi-jet to the third generation, which led to Euro 6 compliance and important improvements in terms of consumption, noise reduction, and engine performance. The third generation multi-jet has the particularity of having a slower and more gradual combustion with the same diesel fuel compared to the previous diesel common rail, which is because it allows up to 5 injections for each single combustion. This technology has made it possible to obtain an improvement in performance, especially at low engine revolutions, a reduction in polluting emissions, and has made it possible to have a quieter engine. The multi-injections are managed by the engine control unit based on the engine revolutions, Newton meters required, and the temperature of the coolant. After having seen the basic information on multi-injections, let's take a look in greater detail how and when they are used. Pre-injections, also called pilot injections. They provide a small amount of fuel before the main injection, which occurs at about 30 degrees before top dead center. They are not used to produce much energy, but are mainly used to further reduce the ignition delay, preheating the combustion chamber to facilitate the ignition of the mixture and reduce the shock of self-combustion. Main injection provides 90% of the diesel fuel and produces the energy necessary to set the crankshaft in motion, as it is the only one to vary the amount of diesel injected and therefore the one that allows you to adjust the load desired engine. This occurs around 5 to 6 degrees before top dead center and is slightly variable according to the rotation speed and the map examined previously. Post-injections provide small amounts of fuel injection and occur expanding around 60 degrees after top dead center. These injections also produce no lower and can occur immediately after main injection, post-injection closure, or a relatively long time after the main injection, late post-injection. Mainly they serve to favor the regeneration of the diesel particulate filter by bringing the exhaust gas temperatures up to 500 to 700 degrees Celsius. But they are also used to burn the particulate producing during the main combustion and to cool the combustion chamber after combustion. In any case, this is the technology currently used. But prior to this, the technology called Unijet was used, which did not allow up to 5 multi-injections during the same operating cycle, but a maximum of only 2 injections per cycle. The Unijet technology, commercially called JTD, Unijet Turbo Diesel, for the Fiat Group was applied for the first time on an Alfa Romeo 156 in 1997 and used the common rail Unijet as the fuel system. This used the same principle as the multijet but the substantial difference was based on the number of injections, as it only had 2. The first was smaller and had the function of increasing the pressure and temperature inside the cylinder. The second was the one that injected the greatest amount of fuel, and that led to combustion. Here we are at the end of this lesson on how the engine advance works and how it affects ignition. So, to recap, in this chapter we have seen the operation of the injection advance, how this affects the operation of the engine, and how it was managed in the past and up to the present day. Furthermore, we saw the difference between multi-jet and unijet technology, so we now understand the use and operation of multiple injections. That's all for now. See you at the next lesson.